Okay, let's get started.
I don't know.
Alright, so I'm going to go over the exam first here before we continue covering the question from today's homework. Okay, so we'll get to today's homework, I promise. But I just wanted to go over maybe some of the common things that people miss. In part one, the two common things that people didn't do were mentioning that this had to be a maximization problem, and so they inverted the
I just put 0 instead
objective
of negative
function,
infinity because I knew
but
that
then said it was now a
negative infinity is not a real
maximization
number.
function. So that was one. And then some people said that you had to invert the function, but didn't actually do it with the particular function in question.
Oh, you actually want to
For definitions, I tried to write some clarifications. If you were close but not fully on the mark, what I was hoping from you. But for binding constraints, I was looking for a constraint that affects the objective solution in a way that if you change that constraint, it's going to change the overall solution, right? If you make it bigger or smaller, depending upon the direction, that's going to change the objective solution. And some of you mentioned that there could only be two binding constraints. That's not true. We saw that as an example in the homework that we did for today. You can have multiple binding constraints. It's easy in a two-dimensional space to have just two binding constraints, but when you start going into these more than two variables, more than two dimensions, it's really easy to have more than just two binding constraints. So you don't want to say that. The shadow or the dual price, some people didn't always connect that to a constraint. Or maybe they connected it to constraint, but they didn't say what was changing about the constraint. Specifically, the value of the right-hand side is changed. So I wanted to make sure that you made that connection, that each constraint has a shadow or a dual price, and specifically, it is for every unit increase in the right-hand side, the shadow price says how much you would expect the value of the objective function to increase as well. So those are tied very closely to each other. For the slack variable, I was looking for specifically that you tied it to a constraint that had a less than or equals inequality. Because if it's a greater than or equals inequality, then you get a surplus variable rather than a slack variable. Some of you accidentally mentioned the wrong inequality type there. And then, once you mention that, what you're saying for that slack is it's the difference between if that constraint represents a resource, how much of that resource is unused. If it represents time, how much time is unused. It's the difference between what you're using for your variable and what the constraint allows you to use for that variable. All right? And then finally, the artificial variable. This one probably was the most difficult for the class. Remember, the artificial variable we specifically inserted into our models to be able to solve it with the simplex method. Because when we had now not a less than or equal inequality, but we had a greater than equal inequality, we subtracted our surplus value. And if that's all we did, the default guess for our surplus values would end up with a negative value. And that negative value violates the logical constraints that we impose on all of our solutions. And so we introduced an artificial variable. Some of you very rightly stated that what this does is it moves the solution space of our simplex method to allow us to have that initial guess of our variables being all zeros. And so the artificial variable is only put in place for those greater than or equal constraints, specifically so that we can solve it using the simplex method. Okay. It's and so that's what it's used for. All right.
Okay.
I'll quickly go through part 3. A was linear. B was nonlinear because you're multiplying two variables together.
I got 2 points.
C was nonlinear because you're using an exponent larger than 1. D was nonlinear because now you're using an exponential value where the exponent is the variable itself. E is nonlinear because you're dividing by two variables. And F is linear because if you look at the very last thing in the statement at the top of the question, it says consider any uppercase value as a constant. So a squared was a constant because a was a constant. All right, so that's those right there. You guys did a great job on question 4, drawing the lines, showing where they intersected. The few problems I saw on question 4 were accidentally putting the feasible region in the wrong spot. So the general shape of the line, the feasible region looked like this because you had some lines like this, and the feasible region should have been up here, but just a couple of you put that feasible region in here, which if you think about it doesn't make sense because we have to be above this line right here, and this feasible region is completely below that line right there. You have to be above all 3 of those constraints. I graded part C assuming that your feasible region was correct. Okay, so you didn't lose points in part C if you misidentified the feasible region. This is where point P was, and the value of the objective function was approximately halfway between the two constraining lines, something like that, right there. It has a slope of -3/2. Alright. For question 5, let me see, there are a couple of things I want to point out here. I need to intererase. Can you pass me an eraser?
Get it. That's why you're a kicker.
All right. So, for question 5, some of you did not even put the new objective function up there. Okay, and so you lost points because you did not include the new objective function. It should have been maximized 27x plus 293y plus 32z. And some of you put minus 0s1. I put a plus on your thing. I didn't mark off points for that because you're multiplying by 0. It doesn't matter if you add or subtract. But just to be consistent, we normally put plus. And then some of you forgot to include the artificial variable. And that's why it's important that this objective function be included in here, because we have to add the artificial variable to this objective function because we have a greater than or equal to constraint right here, specifically in the first constraint. Okay, so you need to make sure that you include that to make sure we can solve it, but then drive this artificially introduced variable back down to 0, so we get a solution that matches our original model right there. And then, I won't write out these full equations then, but this didn't change much, except we subtract off S1, add in this artificial variable. And a lot of you didn't change these two equalities. That needs to be done. That's an important part of that standard form. That's the whole purpose of introducing this surplus variable and this slack variable here is to get us equalities. And similarly, we add S2 with an equality and our limitation. There were a couple other errors, like some people put the zeros that belong here in front of these, and that doesn't make any sense because if you have a 0 here, it might as well not be in this equation anymore. Right? A few of you put the M right here, okay, and that's going to be a different equation then, and not solve what we want to. The M shows up here in this objective function right here. Okay, so those were probably the biggest common errors that I saw in question 5. Part A. Part B, there was a bit of confusion here on what I meant by what are the starting basis variables. Most of you got that, but then, and what are their initial values? There was a lot of people who missed that part. Okay, and so if we think about this, turning this into the simplex method, we know that it's going to look something like this, where we're going to put x, y, and z here. We'll put S1, S2, and A1 here. And you rightfully would think about putting these coefficients right here. But these are coefficients. These are not the values of these variables. A lot of you answered these values because you knew the starting value here was A1, and you knew the starting value here was S2, and that you copy these coefficients over here, minus M and 0. These are not the starting values of these variables here. We've just copied them from here, from these coefficients, from our objective function to make it easier for us to do the computation. These are not the values of the variables. The values of the variables are the values that are over here. Okay? The value of A1, when we start, is 123. And the value when we start of S2 is 9,500. Because of the way we've intentionally constructed the simplex to work, this is the only non-zero value in this equation. And since all the other values in our equation are 0, that means that A1 has to be 123. And the same is true of this equation. The only non-zero value in this equation is S2, which means that S2 has to be 9,500. So the answer for part B is A1 and S2 are equal to 123 and 9,500 respectively. Okay, those are the values that they take on when we make our initial guess. Okay, and that idea of we having these variables over here and we having these values over in the right-hand side, those are always equal. Whatever variable is over here is going, for the current iteration, its value during that guess is exactly equal to the value over here. So if you would turn to the next page and look at the simplex method there at the top where it was filled out, the current values of the variables there are that x2's current value is 3, s2's current value is 8, and S3's current value is 4, because we have our variables there on the left-hand side of the simplex method, and we have those other values on the right-hand side of the method. And because we've intentionally set up our equations to be only non-zero values here, and we have those unit vector properties in the middle here, we get exactly that variable equals value behavior at every single iteration. Yeah, Jason.
This might be beyond the scope of this, but, so your right-hand side is equal to your left-hand side. Is there a way that you can put, the values with respect to, so like, instead of doing 123, is there another answer you can give in terms of M? Or is it?
No, because M just stands for some arbitrarily large value. Right, and this is the coefficient that's in the objective function. That's how much this particular variable affects the objective function, but they should not, these values right here that we use for coefficients should not be tied to the values of, the current values that these are guessed at. So they're not directly tied to each other, and so we can't compute one from the other.
So what does the 0 mean again then, like for S2?
That means that no matter what value we assign S2, it does not change the value of our objective function. Right? It's this 0 right here.
Yeah, okay.
Which is what we want, right? We want to keep track of our slack and surplus values, but we don't want slack to help us, nor do we want slack to hurt us. We don't want surplus to help us, nor do we want it to hurt us, unless that is part of our constraints, and then it has to go into our model rather than into these implicit variables. Yeah. If we did really care about that, we'd put a constraint in there, or we'd put a value into our objective function.
I'm just pissed right that.
Right. All right. Part 6. I think everyone got part A right. Most of you got part B right. The people who missed on part B forgot to divide that right-hand side right here by the column that is x1. Or you have to divide those values first. And then you pick the smallest value rather than the largest value. Because I wanted to see your computation, I wanted to see your division actually take place. So most of the points we're actually doing the division. They're not for your answer. Whereas the answer had already been computed for you for part A. Alright. Part C, basically the way I graded this is I took a half point off for each incorrect value in that box. Alright. And part 4, I graded based on the answers that you computed, not based on the correct answer. So if you made a miscomputation in part C, and your part C said that this was done, then I graded it based on you saying it was done, and vice versa. So I wasn't looking for the right answer based on correct computation. I was looking for the right answer based on your interpretation of your computation. All right. So the answer was supposed to be yes, it's done, because all the values in the Cj minus Zj row were 0 or negative. Some of you may have gotten full credit for no, it's not done, because you had a positive value somewhere in there, right? And that would have been okay as well. All right. Question 7. Binding constraints. The binding constraints here were the percent allocation and the 2001 returns. And you specifically can tell because the shadow price is non-zero. Some of you noticed that those were the only two that had an allowable decrease. Okay? You cannot tell from allowable increase and allowable decrease whether something is binding or not, because you may be just on the edge of a constraint being binding, and so you may only be able to move that binding constraint in one direction to keep it binding. So you cannot look at those allowable increase, allowable decrease values to determine whether something is or is not binding. You have to look strictly at the shadow price, and some of you also noticed correctly that the final value column gives you that information as well. But the allowable increase, allowable decrease columns can be misleading. You cannot use those to determine binding of your variables. All right, part B. There was a lot of discrepancy here between scores. All right, so when we're looking for the range of coefficients that would still result in the optimal solution, we're talking about the decision variables, the first table in this graph. Okay? What we're saying is, if we were to put this in terms of a profit maximization thing, the decision variables are how much of each product to produce, and the coefficients are how much we're going to sell them for, or how much profit we're going to make on them. And the question is, how much range can we change that profit value by and still get the same answer for how many of each of those products to produce? Okay. Most of you realized that you needed to look at the allowable increase and allowable decrease columns in this table. But what you did with those values was where things got a little haywire. That allowable increase and allowable decrease are in relation to the current value. So let's take the first one as an example. And I'm not going to go to the decimal place here today. I don't think that's necessary to get the point across. So for this one, the percent allocation for the 500 index, the current coefficient we can find by looking at which column? Which column can we look at to find the current value?
Objective value?
The objective value. So that's 8.058. And this allowable increase, this allowable decrease, are how much we can go this way and this way by subtracting or adding values. Okay, so what you should have done is you should have subtracted the allowable decrease, and you should have added the allowable increase. So the allowable increase is 11.1. So our range up here would have been like 19.158 or something like that. Our allowable decrease is in spreadsheet talk 1e plus 100. Some of you asked me what that meant, which is cool. This is just a way to represent really big numbers. Specifically, this is 1 times 10 to the 100th power. Okay.
What do they also add 100?
Huh?
Why do they also add 100 then?
This plus represents a positive 100 here. Okay. So let me give you another example. Let's say I said 4.2e minus 28. Okay. What this means is 4.2 times 10 to the negative 28. Okay, so this is just scientific notation in a really compact representation, where this is the magnitude, and this is the exponent, that's what the E stands for here, exponent. And since you know the format of it, you can just put the 10 to this power right here. Okay, so the 1e plus 100, this is basically the largest number that the spreadsheet can represent. It's basically representing infinity, negative infinity in this case, because you're subtracting. So your range is, you can subtract as much as you want. Any coefficient smaller than 8.58 would 8.058 would have been okay, up to this maximum of 19.158 right there. Okay, and so you do that to get your final value. Yes.
So just to clarify, the objective value is the value of the coefficient, and the
Yes.
final value is like the value of the variable.
Yes. Yes,
Okay.
so the final value is
Would be like X or whatever.
yeah, so
Okay.
you would have,
So it'd be, so the first one would be like 8.058 times 0, so it's really
Yes.
0.
mhm,
Okay.
okay? So that was part B. And I just gave 1 point for each minimum and maximum values in those ranges. Part C. If the right-hand side of the first constraint changes, okay, that right-hand side is already a clue to you that we're going to be talking about a shadow price here, okay? Now, some of you interpreted the shadow price exactly opposite of what it's supposed to be, and said that the shadow price only applies after you get outside of the allowable increase and allowable decrease. But it's exactly opposite. The shadow price only applies within the allowable increase and allowable decrease. As a little insight into me writing this problem, I originally wrote the problem that said if the right-hand side of the first constraint changed to 2, how would you expect a value? Because I thought, oh, that'll be real easy. Then you'll just copy down the shadow price directly from the table into here. But then when I looked at that allowable increase and allowable decrease, I had to change the text of the problem because the allowable increase only allowed 0.168 to take place before that shadow price was invalid. So I changed it to something that was almost as easy, 1/10. Because if moving 1 changes the shadow price by 12, moving by 1/10 is going to increase the objective function by 1/10 of the shadow price. So I figured dividing by 10 is pretty easy to do. You wouldn't have to work hard to divide 12.4 by 10 and get the new answer. But you were very right to look at that allowable increase and allowable decrease, but that tells you the range that it does work, not the range that it's invalid. Okay? So, the two primary mistakes that people made here were, one, misinterpreting the allowable increase, allowable decrease to exclude rather than include. And secondly, some of you did not take into account that the movement of the right-hand side was only 1/10 of a unit. And so you didn't divide the shadow price by 10 to get the change in the objective value as a result. Some other things are that a few of you said, oh, the final value there in that line is 1. I'm going to add 1.24 to 1, and that's what my new value is. And no, that's not the final value of the objective function. That was the final that was the final value of that slack or surplus value, right? Or actually, it's the final value of that equation. So you don't want to look at that final value and add the shadow price to that, because I was asking for the final value of the objective function, not the final value of an individual constraint along the way. So what we don't want to get is an answer of 2.24, because you don't want to combine those two values together. They're two different things from each other. All right. If I didn't address a particular question that you had about your exam, please come talk to me. I want to make sure that you understand why you got the grades that you did, and are able to fix it. If you are unhappy with your grade for some way, if you think I graded it wrong, please come see me. I want to make sure that you get the grade that you deserve. If you're unhappy with the grade but you think it was fair, come talk to me and we can start working on trying to get you caught up in understanding this material. This last question right here is the exact type of thing that we're continuing to do here in chapter 4, where we're taking these sensitivity analyses and trying to interpret these models in an effective way. So you need to make sure that you are able to understand the dual or the shadow, that you're able to make analysis from the reports that these models produce. So definitely talk to me. I want to help any of you out for that. I think some of you already asked me this, but the average score I think was 79%, and yeah, there's a full range of scores from high through low. So I was pretty happy with the overall performance of everyone. And
There's so many little things you could scroll.
I'm just trying to log in here.
Yeah. When you ask where in the questions, well, not ask where, he says where.
Why don't you, while I'm logging in, pull out your laptops, because we're going to go over the assignment for today.
Did you get it? I think we figured it out.
I didn't figure out part.
I
I didn't figure out part.
think I figured it out. No, the A, B, C, D. Those were sneaky. I think I figured out D. I was not present. Hey, just a quick question for you. How does one download this thing?
What are you doing there? That's like weeks ago.
Yeah, but you did it. Why wouldn't you?
Alright, and I'm sorry for those of you who are having trouble with your OpenSolver plugin. I haven't had a chance to chase those down, but hopefully you're able to use the built-in solver add-in until I get that taken care of on your machine. If not, you can always use the CSE lab machines. Those are available for your use. Alright? So, 4.7, we started looking at it very, very briefly at the end of class on Monday. And I started putting up some equations that will hopefully get you on the right start for this problem here. Alright, so we said that we were going to designate F to be our cash settlement. This is what we're going to pay. We said that G1 was how many of government security 1 we were going to buy. G2 was how much of government 2 security we were going to buy. And then we started building up our equations. So I think I did something like this. If we start with our cash settlement, that's our starting amount of money, and we take away the initial payment of $190,000, then we can also take away how much we're going to use to buy these government securities. So, since this is in thousands of dollars, we would put it there, because we had the purchase price for government security 1 was $1,055, and the purchase price of government security 2 was $1,000, so I can just write government security 2. So this is how much I start with my cash settlement. This is how much I have to pay the client, or the plaintiff, whatever. This is how much I invest in government security 1. This is how much I invest in government security 2, and that leaves the rest in savings. Alright? So we can rearrange this equation, which we didn't do on Monday, to put this on the right hand side and put all our variables on the left hand side. So we can do something like F minus S1 minus 1.055 G1 minus G2 equals 190. And this, you could also say greater than or equal to would also be legal, because we have to have at least $190,000. But it turns out equal will get us the right answer, because if you think about it, we don't want to have any extra money. So the greater than is not going to matter, right? We're trying to minimize the amount available. So it's going to end up being on that equal sign anyways, okay? So either way works. So this is our first year. Our second year, then, is going to start off with the money that we had in our savings instead of the money that we paid out initially. And then we have to do the same type of thing. We subtract off how much we owe, now $250,000. But now we don't have to make these purchases anymore, right? We're not continuing to buy the government grants. And one of the reasons why we can't do that, just as an aside, is we can't predict what the cost of these government grants will be in the future. We can only buy the government grants at the time of the settlement, because that's the only known price that we have available to us. They might go up, they might go down, and so it's not fair to the settlement to have that uncertainty in the equation. So you can only include prices that you actually know. But what we do get out of these government grants are interest. Right? These bonds return interest back to us, specifically 6.75%. So we're going to get 6.75% for each bond that we buy. And the other one we get 5.8%. Plus, since this was in savings for a year, we get interest from it as well. And if we take all that, that's what we're going to squirrel away into our savings at the end of year 2. And we can do the same kind of manipulation of this equation as we did before. So it's going to look like S1 plus 0.0675 G1 plus 0.05125 G2 plus 1.04 S1, because I'm combining this and this together, minus S2 equals 215. All right?
It's 3:40 p.m.
Is everyone following that? Does that make sense to everyone? Is there any questions about that? I don't want to have to do all 7 years, because I think if we get these 2 years, we get most of the thing, and I'll start putting it in the spreadsheet, and then here, yeah.
That's what I should have.
Okay. So let's start putting this into our spreadsheet then. Okay, so I always like to start with our variables, and so initial settlement, I'll just put in parentheses F here. Year 1 savings. How many years of savings do we need? Why? What was that?
So we carry over from
Okay, so how many years of payments do we have? We have 6 years of payments, so we're actually going to have to incorporate a year 7 of savings, just in case there's something left over. Okay? We need to be able to, well, actually, sorry, I'm looking at my Part D, which is the part payments. All right? So, these are our variables. What is our objective? We want to minimize this amount right here, right? So, Some of you may have done something like put your objective as a separate here, and then you just put equals B1. And that will work. Okay, that will work, but you didn't have to. You can actually, if we go to the model, I'll start entering the model beforehand. We can make our objective cell be B1 directly. And we can then make our variable cells include that objective cell. Okay? And so you can see that it's highlighted that cell as both being a variable, right? It's got this pink, purple color, whatever it is. But then it's got that darker highlight around it with this minimization here. This particular cell is also the objective of our minimization right here. Alright? So you can do that. And in fact, you will probably start to do this as we get past chapter 5 into chapter 6, when we start doing transportation and transshipment problems. This is a very common thing for us to do with our models. Okay? So you didn't do anything wrong if you separated it out. Okay? So our initial payment, let's put this in here, right here. It equals B1, our initial settlement, minus B2, our savings at the end of the year, minus 1.0, well, yeah, 1.0, 5G1, which is, oh, it's a problem, isn't it? These aren't our only variables, are they?
Got the G.
Remember, G1 bonds, number G2 bonds, okay? And then what I'm going to do here, I'm going to put off to the side here, I'm going to put the purchase price, and I'm going to put the interest rate. And the reason I'm doing this is because if we want to have a model that's useful for exploration, we probably don't want to have these values, the purchase price and the interest rate, deeply embedded in a bunch of functions. We would like to be able to say, oh wait, interest rates changed. I want to be able to update them and have our entire model reflect those updates quickly without having to change tons and tons and tons of equations that reflect that. So I'm just trying to be a little bit more generic here. Nothing again was wrong with your models if you put these directly into your equation. So the purchase price is, for government bond 1, is $1,055 per bond, and the interest rate was 6 3/4, right?
What am I doing? Another question?
Because all of these values that I put here were in thousands of dollars. So if I wanted to make it 1,055, I would have had to make sure that these were also in thousands of dollars, and make this 190,000, make this 215,000.
We didn't even write those down.
So either one's completely valid, again. And the purchase price here is $1,000 and an interest rate of 5 1/8. So let's try this again. Initial payment is the initial settlement, B1, minus our savings, year 1 savings, B2, minus, now we can do E8 times B8, right? I can multiply these together, how much I purchased it by how many I'm buying, right there. Minus E9 times B9. So that's my purchase of the 2 government bonds right there. And then that should be equal to $190,000. I'll highlight that real quick. Does everyone see that? Okay, let's go to year 2. Now we go B1 minus, sorry. Let's do this. Savings rate. There we go. Equals B1 times B2. And now we get our interest. B8 times F8 plus B9 times F9. So that's this and this.
Just hard coded.
And then we're going to subtract our next savings, which is B3. Yes?
Should it be B1 or should it be both?
I changed it while you were asking me the question. Thank you. Yes. Start with year 1 saving, that initial settlement. And this one should be 215. And we keep going here, right? So now we do B3 minus B8 times F8. Plus B8 times F8 plus B9 times F9. Wait, let's go up here. We need to get the savings rate here, times U2, minus B4. All right, and this payment is 240, right? Let's keep going here. Now, wait, I already messed up. Okay, we will pick this up on Friday. But what I messed up here is I forgot that these bonds come due, right? And so we actually get to sell all these bonds for the par value of $1,000.
Boys ready? Go hurt some people.